10.3, we are talking about probability here. Then we'll start out talking about theoretical probability. Then we'll talk about odds. Odds get used interchangeably with probability a lot, even though they shouldn't. We'll also talk about the difference between probability and odds, and then we'll talk about experimental probability. Okay, so first let's just talk about probability. Okay. So for probability, we first have to talk about an experiment. Okay, so here's an experiment. An experiment can be roll a die, deal out a hand of poker, spin a spinner, flip a coin. These are all experiments. Okay, and then whatever the experiment is, you got to describe exactly what it is. So if it's rolling a die, an outcome is like the most basic thing you could talk about. An outcome is, so if this is roll a die, let's just use one example. Okay, so roll a die, an outcome could be get a 6. Okay, another outcome could be get a 5, get a 1, get a 2. So how many outcomes are there? There are a total of 6 total possible outcomes for rolling a die. Okay, now we can take several outcomes, or just one outcome, and that would describe an event. Okay, so an event could be also just get a 6, but an event could describe several different outcomes. It could be roll an even number. It could be roll a number less than 5. It could be roll, some kind of a description that describes the kinds of numbers that we are looking for. Roll a side of the die that has a pip. That's the name for a dot on a die. It has a pip in the center of the face. These are all different ways we can describe events. Okay, so once we're down to the event level, now we can talk about probability. Okay, so let's name this event, whatever event we care about. We'll call it event A. So the probability of event A is the number of outcomes. Okay, so let's talk about outcomes again. Outcomes are the very basic results you can get depending on how you describe your experiment. Okay, so rolling a die, and then you also have to kind of record something. That's the best way to think of an experiment. So roll a die and record the number, right? So now our observation is about the number, and so the outcome is the most basic thing that you could record about the number. That it's basically 1 through 6. That's what you write down. And an event would describe, outcomes. Different kinds of outcomes could be all together. So the number of outcomes in A, right? We'll do some examples here in a second. And then in the denominator, we put the number of outcomes total. All the possible outcomes in the experiment. Okay, so in this example, the number of total outcomes is going to be always 6. Always going to be 6. Okay, so what's the probability of getting an even number? Okay, so that's event A. So how many ways, what number of outcomes are there in A of getting an even number? Where you got 2, 4, and 6. Those are all the even numbers. So you got 3 outcomes in A. The total number of outcomes is 6. So 1/2. Okay, what's the probability of getting a pip in the center of the face? Let's see. We got 1, 3, 5. 1, 3, and 5. So that's 3 out of 6, also 1/2. Okay, what's the probability of getting a 2? Well, that's just there's only 1 2 out of all the possible outcomes, and there's 6 possible outcomes. Okay, so no problem there. So now let's talk about odds. And just before we talk about odds, I'm going to reference this definition over and over and over, because when a problem seems complicated, we'll go back to number of outcomes over total outcomes. Number of outcomes in A over total outcomes, or total number of outcomes. So just keep that in mind. Log that away. So odds are very similar, except for odds Okay, so if we're talking about, there's two kinds of odds. Odds for, okay, odds for A, well, that would be number of outcomes in A. Okay, very same exact thing as the probability, except for in the denominator we have number of outcomes not in A. So how would that be different? What would be the odds for, or odds in favor, positive thing, odds in favor of A? Actually, it's just odds in favor. Odds in favor of A if A is getting an even number. Well, how many outcomes are there in A? 3. And how many outcomes are there not in A? Okay, so the total is 6. So how many outcomes are not in A? Just 3. Right? 3 times out of... you should expect over the long haul that you should get a 3-to-3 ratio or a 1-to-1 ratio of times you. This is, if you think about betting on this thing happening, you'll win once and you'll lose once. You'll win once and lose once. That's kind of how you can expect your luck to be over time. Okay, so odds against is just the reciprocal of this. Okay, now it's like how often are you going to lose versus how often are you going to win. So what would be the odds against getting a 2? Well, how often will you not get a 2? Okay, 5 times out of 6. And how often will you get a 2? 1 time. So you would expect if you roll it 6 times, you would not get a 2 5 times, and you would get a 2 once. Of course, that's not going to be the way it actually is in the small number of 6 rolls, but that doesn't simplify at all. 5 to 1, right? When you hear about odds, when you hear about a boxing match or a football game or anything like that, they'll talk about 5 to 1 odds, and they're really talking about the odds against that team or that horse or whatever. 5 to 1. So if it's 5 to 1, and you bet on you win, then you get 5 times as much as you put in. So that's kind of the way that works. Okay, so this we should really qualify as theoretical probability, and then experimental. Let's talk about that. Experimental probability. Okay, so theoretically, the probability of getting a 2 is 1 in 6. There's one side that has a 2 on it, and 6 sides total. So 1 in 6 times over the long run, you should get a 2. Okay, but let's say you do this experiment 36 times. Okay, and we record all the 2's, and we wind up getting 8 2's, right? So this would be, put 4 in there. So this would be 2 out of 9. Okay. So 2 over 9 is the probability, or the experimental probability. We actually rolled a die 36 times, but we got 8 2's. What should we get if we roll 36 times? The theoretical probability would be that we would get 6, because it should come out to be 1/6. Okay, and 2 9ths and 1/6 are not terribly far away from each other. This thing called the law of large numbers says, though, that if we did 100 experiments, and then 1,000, and then a million and a billion, the more experiments we do, the law of large numbers says the the experimental probability will approach the theoretical probability. Okay, and if it doesn't approach, if we did this a trillion times and we didn't have a number that was almost exactly 1/6, we would start to expect that there's something wrong with the die that we're using, or there's something strange about the way that we are rolling it. Maybe we're rolling it in a really predictable way. But if it's truly random and it's a truly fair die, the law of large numbers says the more experiments we do, the experimental approaches the theoretical. Okay, but the basic definition of theoretical probability: odds in favor, odds against, and experimental probability. So we'll do more specific examples in the sample problems video, but thanks for watching.